Hey there, Internet. I'm gonna try to grind the eccentric on here. I've changed my setup. I've got CNC control of this axis as well as the rotary axis. I'm gonna hand feed this way, and we're gonna see if we can't do an eccentric grind. So, okay, so that worked. Um, I just had to reset it because I sent it. I was about to send it off the bearings here. That worked. What I didn't consider here is the step over. So I don't know if this is 1 millimeter thick or not, but essentially I was moving 1 millimeter for every rotation. So I think that's about half of what I want, and I should go. I probably want to spin quite a bit faster. So I'm gonna kind of zero and try that again. So let me get my. Wait, stop, reset. What was that? Oh, I got it set to 10 millimeter jog. It's terrifying. Okay. So we will start here. Triple feed rate and much less step over. I'm going to feed in 30 hundredths of a millimeter, 3/10 of a millimeter, and then I'm going to do an 8 millimeter pass. I think so. We will see how that works. So there's 10, 20, 30-ish, and cross our fingers that nothing goes wrong. Here we go. The first thing I notice is it's completely cool to the touch, which tells me I can go quite a bit more aggressively. Um, it's not it's not smooth. Um, this is smoother, so I don't know. There's a lot of stick out here, so that might be causing a problem. I'm not really sure. It could be the slower feed rate. So I'm gonna go ahead and double the revolutions feed rate again, and take another pass. So I'll be back. I don't think you want to watch that. I've got a pretty good eccentric on there now. Um, Obviously, I didn't really think about the the tool when I rechucked it, but it's no big deal. This is really just a test. So what I'm going to do next is I'm going to just spark it off. So the surface finish is definitely rough. I'm going to spin it about. I'm going to try to spin it 3 times faster, but not feed in this way at all. So that'll be my next thing here. So I'm going to get set up, and that's what you'll see next. So I took the final pass. It looks really good. Um, I noticed one problem here that I noticed a problem here that the vibration was loosening this back coupling here, and the 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 way the spindle cartridge works is there doesn't seem to be anything holding this in place except for maybe this pushing in. Because if you take this off, you can slide the cartridge. It's free to slide in there. So I got to figure out how to tighten that properly. There's no facet or anything to crank on that. But the quality of the grind looks really good. So what I want to do next is I'll take it out of the vise. We'll take it over the microscope, and we'll have a proper look-ski at it. Here we are under the microscope, and this top surface here, this is where I broke that carbide because I didn't know that. Well, I didn't look at this close enough to realize it was high-speed steel. This is the first grind that I did, hand-fed, and you can see what that looks like. I think you can see the depth is totally not consistent, and that's the weeble wobble from the X1 mini mill table. That is absolute garbage. Then we make our way down here. I think this is residual from my first try, hand feeding. And then you can see here we've got a very rounded corner here, which I'm going to guess is because that cutoff wheel is bending. But this is the original finish, and this is the finish that I got with that final pass, which was about 0.05 of a millimeter, roughly. Oh, I know what happened here. So this is rounded over because my CNC controller reset and I lost position. And when I fed back this other way, it took a bigger bite on this end than it should have. It didn't quite know where it was. You can see that this shoulder here is quite a bit more square. So, that's the transition right there on this back. Now, the grinder didn't touch the back. I didn't fully grind it all the way. So that's the factory grind. And that's the cutoff wheel CNC grind, which I think is really good. And if you just look at it with your old man eyes like I have, which I'm not finding it more and more difficult to see things close up anymore. But I would say that this is a really fantastic result. Now, there's a couple issues. The main issue, I think, is the amount of time it takes. It's not fast, and I think that's a function of the diameter of the grinding wheel. There's really not much you can do about that. So it's likely, going to take a lot of time and dramatically shorten the life of your rotary tool. If you want to hand feed it, you can probably do better than this with
with a linear rail instead of a dovetail with a poorly adjusted gib. And if you want to, if you want to have a very fine feed that's CNC controlled, it definitely works well. And you really only need to have, well, you don't even need to have, you need a spindle, a rotary axis. Mine happens to be CNC controlled, and then you just need to feed the thing kind of back and forth in here. Now, I could facet this, and that brings up other opportunities where, I could actually turn this into an end mill, I think, by essentially doing the same thing that you would as far as synchronizing the movement this way with your rotation, which I can do in my setup. But anyway, I think this is definitely feasible, hand fed. It's feasible without a rotary axis. It's surprisingly good quality as far as I'm concerned. And I think if you want to, make a lathe tool, this is definitely not the worst way to go about trying to do it. Thanks for watching.